Hello guys, today we are gonna solve another problem from CSES Problemset, and the question name is building roads, which is from Graph Algorithms. So let's go and look at the question. So we are given by land and it has n cities and m roads between them, and we need to construct new road so that there is a route between any two cities. So we need to find out the minimum number of roads which we need to add so that every road is interconnected. In the input we are given n and m, that is 4 and 2 in this case, and the edges in between them, right? So 1 and 2 has an edge and 3 and 4 has an edge. So what we need to do is we need to create more edges so that all of these components get interconnected with each other. So I think what we can use is just a DSU data structure, but it would be a little complex. So I guess we can solve this question simply by using DFS as well, or any traversal algorithm. We just need to find out that what are the number of components which are there and how are we gonna connect each other, right? So let's try to write the code for this. Let's first copy the input, and we are first of all given n and m. We have to take it in input as well, and then there are m edges. So we can say vector of vector, and let's call it input only, of size m, and m cross 2 is the size. Okay, m cross 2. So we can take input like this, I less than m, I plus plus, and there are two variables. So we can say int a comma b. We have to take it input as well, and we can just store it like this. Input of I comma 0 would be our a, and similarly input of I comma 1 would be our b. After that, from the question we can understand that it is a graph problem only, and we just need to find the number of connected components, and we also need to print out that what are the edges you would require to add so that it forms a complete graph, right? So what we can do is for each component we can assign a node as its main node, and after that, okay, let's write the code and I'll try to make you understand while writing the code only. So we are creating adjacency list to traverse into the graph. It is of size n plus 1, because it is 1 based indexing, means 1 to n are the nodes, right? So that's why, and we can also store it into adjacency list here only. So adjacency of b would be a, and that's great. This won't be equal to, this should be pushback of this. Similarly over here as well. After that, we have created an adjacency list, so we just need to apply any algorithm. Let's use DFS for simplicity. So to do that we need a visited array which is of n plus 1 size. Instead of int we can use boolean and initially all are marked unvisited. After that we would start traversing, like I less than equals to n I plus plus, means we can just start from 1 as well because it is one based indexing. And if it isn't previously visited, then we have to apply a DFS call, and also we would require adjacency list as well as visited array. After writing the let's write DFS function right now only. We would require a node, adjacency list, and a visited array. Visited, right? And first of all, DFS has, first of all we need to mark it as visited, then we can traverse into its adjacency nodes, that is adjacency of that node. If it isn't previously visited, okay, then there would be a call for that neighbor, and that's all. And what we can do is, for which the DFS is called, we can just store that number into a vector. Let's call it temporary array only. So, or you can say start node, that is from which the whole DFS is begun. So, and we would be storing it into the start node array, that is the number I. So what we are essentially doing is, if a DFS is starting from 1, so what it will do is it will push back into our start node array, and we know that there is a component starting from 1. It would mark all the nodes visited which are there in that component, and after that if another DFS call is begun from 3, so it would store 3 into the start node array and mark everyone 3 and 4 as visited. After that we would have 1 and 3 node, and after that we just need to connect that. Okay, that's the main funda. So we are essentially having this number of components, that is the size of this node, right? So to connect them we would require start node minus 1 edges. So start node dot size minus 1 would be the edge required, and we just need to connect it, like we can just do start node dot size minus 1 and I plus plus. We are doing that 1 and 3 are there, so 1 and 3 get connected with each other, so we can just see out like this, and start node of I plus 1, and that's all. I guess it should run fine. Let's try to run it. Yes, it is giving correct expected answer. And let's try to take another example just to be sure. There are 5 nodes and 2 edges between them. Let's say 2 and 3 are connected and 4 and 5 are connected. So let's try to see if it is giving correct answer for this as well. Yes, so 2 edges would be required because there are 3 components, and 1 and 2 should be connected, and similarly 2 and 4. That's it, I guess. So let's just submit it. Okay, I need to open VS Code and try and submit the code. First of all, let's run it just to be sure that we are not making any silly mistakes, and paste it over here. Yes, the answer is correct, and now we can submit it. So it should be in this. okay, this file, and let's submit it. Yes, it is accepted. So that's all. Thank you so much for watching. Bye bye.